in our agriculture statistics or any kind of data analysis part. First, it summarizes the large data, represent the whole data set with a single value and easy to comparison. And last one is it is a basis for the further analysis like variance, standard deviation, correlation, etc. Definition. The main purpose of of the central tendency is to give a single value data which represent the whole data set. Like and it is the central tendency means the central value. I already said that, and is aimed to provide an accurate description of the entire data. Measure of central tendency can divide in three parts. First one is mean, median, and mode. In the first, we take the average numbers, and then median. Median give you the median share number of the ordered data set. And the last one is the mode, which is most frequent value which is occurring in the data set. You can also say that statistical average general tendency can divide it in two parts. First one is the mathematical average, which is divided in three parts: arithmetic mean, geometric mean, harmonic mean, and the positional average like median and mode. Characteristic of a good S measure. Yet if it is based on all observations, easy to calculate and understand, not affected by the extreme value, rigidly defined, capable of further mathematical treatments, and least affected by the sampling fluctuation, then we can say that the data is it is a good measure of the data. First one is the arithmetic mean. Arithmetic mean is simple. If I take the example, like in this case, we can say the data is given as the 18, 20, 17, 22, 19, 21, 16, 33, 23. And if I want to say that how to calculate the mean, just first we take the sum all the values and divided it by the number of the observations. In this case, the n is 8, so the value will be 19.5. Now, when it is for the ungrouped data, when the data is given in a single form. When the data given in a group form like the in some interval, then in this case x is not known to us. So we first want to know what is our x. X is the midpoint of the variables. Then we take the summation of the fi, and then we multiply f and m and take their sum. And last one is the divided the fm by sum over f, and this give you the mean of the data. Next one is geometric mean. Geometric mean is the product of the nth observation and take their nth root. In this case, I take example of some crop production growth factor for 4 years. For the first is 1.12, 10, 2 is equal to 1.20, and 3 is equal to 1.15, and 4 is equal to 1.125. If I multiply all the x1, x2, xn and then take the square root by n, n is equal to 4. So your geometric mean will be 1.17. Next is the harmonic mean. In harmonic mean, it is the reciprocal of the arithmetic mean. In this case, the formula is h is equal to n by sum over 1 by x. Here it is our the first column is for x and second column is for the speed or what is the speed of the car or anything. So say here it is the h is your 7.66, and we can say that the average pulling speed of the tractor is 7.66 km/h. Next is median. Median is called the location parameter because it is give you a location. Suppose there is if we have a data like x1, x2, xn, first we have to arrange the data in ascending or descending order, and then we have count the number of the observation. If n is equal to odd, then the median will be n plus 1 by 2 term. And if n is even, then median will be n by 2 term plus n by 2 plus 1 term divided by the 2. This is n by 2 is the position of the data, and this value we have to calculate the value from the data set. And for the group data, we use the L plus n by 2 minus CF by F into I, where L is the lower boundary rate of the median class, CF is the cumulative frequency, and F is the frequency of the median class, and I is the width of the median class, and N is the total number of the observations. Suppose in the here I take the two examples. In the first case where N is our even odd, where for this our median will be N plus 1 by 2, this is equal to the fourth position value. This is our 15. And for the second case, when I take the 8 and n is equal to the number of the event, 8. Then our median will be n by 2 and the position value plus n by 2 plus 1 is position value, and take their sum and divided by 2, then the value will be 6.5. Median for the group data. In this case, the data is given in a group form and the frequency is given. First, you have to calculate the cumulative frequency, and then you have to divide it by n by 2, and it's give you the position of the value where the median is belong to. And then we have to find the L, CF, and the frequency and the interval of the data or class width of the median class, and it gives you the value is the median is 5. Next is mode. In mode, we calculate the highest frequency of the data, which value is most time repeated in the data set. We call it a mode value. In for the group data, the mode will be L plus F1 minus F0 by 2F1 minus F0 minus F2 into H, where the values are where the symbols are given as L is the lower limit of the modal class, F1 is the frequency of the modal class, F0 is just before the previous value of the modal class, and F2 is the just below the value, just after the modal class, and H is the class width. If I take an example, in this case, I have taken the example of the group frequency. Here the number of farmers is given. So suppose in this case, our number of the maximum number is 15. So in this case, 15 is our modal class. 15 is our modal value, for modal value position, and then the L is the lower value, and F1 is the frequency number, that's 15, and then F0 is our 6 and previous class, and F2 is the 10 for the next class, and then H equal to 10, and after all the calculation we get the value mode is equal to 26.43. Merits, demerits, and merits and demerits of the three central tendency value: mean, median, and mode. Mean is easily calculated, and the merit the demerit is it is affected by the extreme values. It is not suitable for the skewed data, cannot be used for the open-end classes interval. Median, it is not affected by the extreme values, and so it is not suitable for the skewed distribution, can be used for the open-end classes. It does not use all the observations, so we cannot say it is a good measure. It is not suitable for the algebraic calculation unless it is stable than mean. And the last one is the mode. Simple to understand, but represent the most frequent value, useful for the qualitative data. Not based on the all observation like the median, may not be uniquely defined and difficult to determine in some datasets. Next is the conclusion. Measures of central tendency summarize the large dataset into a single representative value and help the statistical analysis for the further analysis part. Next is measure of dispersion. In this case, dispersion mean the how much the data is dispersed, like from the mean value. In this case, if I take an example, like suppose there is a student whose students marks are 10, 15, and 12, and their average value is something, and and another case the value is like 12. If I take the value and we can see that the both value mean is same, but we can say that the spreadness of the data is not same. Like in this two example, we can say that the data spreadness is not same. So we can, from the measure of dispersion, we can calculate the spreadness of the data. How can I use which measures we use in measure dispersion? First one is range, second one is interquartile range, and last one is variance or standard deviation. In range, we just take the largest value and the smallest value and subtract them, and we can find the range. Like in this case, I have taken the value. In this case, the maximum value is 9, and the smallest value is the 1. So your range is 8. Semi-interquartile range. Semi-interquartile range is define the difference of the first and third quartile divided by 2. The formula is Q3 minus Q1 by 2. If I take the example in this case, if there is number of the variables are n equal to 10, then the first quartile belongs to the n plus 1 by 4th value. So it is lies between this 2.75. So 2.75 lies between 2 and 3. So value is 5. More departure, it is approximately 5. And the And the third quartile will be the 3n plus 1 divided by 4. The value will be 8.25. So their value will be after between the 8 and 9 term. So it is the 75% of quartile. It is give you the 25. So our in interquartile range will be Q3 minus Q1 by 2 is our 10. Next is variance. Variance defined as the average of the square deviations, which sigma square is sigma square equals sum over xi minus mu the whole square divided by n. Variance tells us how the spread out the data value are from the average mean. Standard deviation, when the standard deviation is the when the deviate scores a square in the variance and there until the measure the square is as well. Suppose if a pupil's weight in the measured in pound, then the variance of the weight should be expressed in pound square. Since the square unit is measured and often awkward to deal with, so we just take the square root of the variance and it gives you the standard deviation. The formula we use for calculating variance, when the value is when we apply the data for the sample data, it is sum over xi minus x bar the whole square divided by n minus 1. N, this is the, in this case sum over xi minus mu is the population mean and n is the number of the observations and x is the number of the observation values. In this case, I have taken a small example for this, where x is the values are 9, 8, 6, 5, 8, and 6, and then we have first calculate the square, and then calculate the mean is mu, then take the x minus mu and take their square and take the sum. After doing the sum, the value of sigma will be 2. Sigma square is variance is 2. In this case, first one is when the in the first x bar, when the x bar is not known to us, we have to calculate from the data, and when the population mean is known to us, we just simply put the value in the formula and we can calculate the value. Because the variance, because the sample mean is not perfect estimate of the population mean, in the formula for the variance of the sample is slightly different from the formula for the variance of population. This is just the difference between the suffix, the division. There is an n and there is an n minus 1. Method of skewness tell us the how the data is distributed along the data set. In the first case, it is called the positively skewed. In the middle one is the skewness is 0, and last one is the negatively skewed. We always measure the skewness about the symmetry. Based on this value, based on this, we can calculate the positively skewed or negatively skewed. If the skewness value is less than 0, then the distribution is negatively skewed. If skewness is greater than 0, then we can say the distribution is positively skewed. And last one, if skewness is 0, then we can say that the distribution is symmetric. Next one is kurtosis. Kurtosis give us the thickness of the data. How much the data is thick. In the first case, we can say that when the data is more thick, it's called the leptokurtic. When the data is mediumly thick, it's called the mesokurtic, and last one is the platykurtic. In all the cases, we compare with the distribution shape based on the Gaussian distribution or the normal distribution. When the distribution is normally distributed, its kurtosis equal to 3 and is said to be mesokurtic. When the distribution is less spread out than the normal, it is called the kurtosis is greater than 3. It is said to be the leptokurtic. And last one is when the distribution is more spread out than a normal, it is kurtosis is less than 3 is called the platykurtic. Now, now I come to the point when the introduction to R. R is an open software. We can download it in any using the internet by the CAN file. It is it is free of cost. Everyone can use it in the analysis part and visualize the data. It is easy to draw the graphs like pie chart, histogram, and box plot, scatter plot, etc. It's work on the different platform like the open source and platform like Windows, Mac, and Linux, and it has a large community support. It has many packages are already installed in the R, so we can use it for the further investigation or further analysis part. Then R variable. In the R variable, we define the variable R by using the variable name equal to value. We can use the different types of data, different type of functions to define the value, like the variable less than equal to value, or value is greater than and then the small is a semicolon and then this variable name. Like in this case, I take example. Like first one is variance as a var one equal to hello, and the print var it also give you the value. It is print the value, and the second one that for the when we to define the value in this manner, it's also give you the result. And when the last case you also you just you represent data in this manner is also give you the same result. Now data structure. In data structure, we use the different type of manners to write the data. First one is vector, second one is list, data frames, matrix, arrays, and factors. First one is vector. In vector, we just how we to write the data. Like first we define an x and then c equal to 3, 5, and 7. Just write it and then run the console and write the print text. It give you the output like 1, 3, 5, 7, and 8. Then was list. List is for the non-homogeneous data structure, which implies that it can contain elements of the different type data set. It accepts the numbers, characters, list, and even the matrices and the function inside. It creates by using the list function. List give you the all the data set in one file. Like if in this case, I have mentioned the student ID. It is C on their ID number is 101, 102, 103, and 104. And their name are Amit, Riya, Sohan, and Neha. And the number of the students are 4. And student list also given here. List is equal to, after when we use the function list, we just first include all the variable like student ID, student name, number of the students. And after print the data, print this comment, the student list, we can see that the outputs are all the vectors in one file. Like 101 is their student ID name, then their name and their number of students. So list is using for the to represent the all data set in one file, in one place. Then matrix. If we want to enter in matrix in R, first we have to write the which value we want to show there. Like in this case, I have take the value is 1 to 9, and then you have to define the number of the rows and number of the columns. And then by row is 2. In this case, there are value are like 2, 1, 2, 3. Their number of row is 3, and column is the 3, and the by row is 2 means the value are showing in a row wise. If we put the by row is false, then the value will be so like in column wise. In this case, 1, 2, 3, and then 4, 5, 6, and the 7, 8, 9. Then the next topic is array. Array is the referred to type of data structure that is used to store the multiple items of a similar type together. This leads the collection of the item that are stored a contiguous memory location. This memory location is denoted by the array name, and the position of an element can be calculated simply by the adding an offset of the base value. In this case, array structure can be in array structure. An array is consisting the following. First is array index. In array index, the array index is identify the location of the element. The array index starts with 0. Array elements are items that are stored in the array. And last one is the array length. The array length is determined by the number of the elements that can be stored in the array. In this case, the array is two types, one-dimensional and multi-dimensional. In one-dimensional array, one or single value can be single array type in the array element can be stored, and the sequence can be accessed in the same order. And multi-dimensional arrays are the array where the elements stored for the more than one dimension. That can be 2 or 3 dimension arrays, can be consist of the row and column indexes. To create the array, we can use the array command. For example, for this example, I have here first one is a vector 1. This is called the C1 to 3, 1 to 4, and vector 2 is C 15, 17, 27, 3, 10, and 12. And the output is array. And then I just write the C, the first vector 1 and the second vector 2, and the dimension is 3, cost 3 and 2. So we can see that the result is in the first data, where I have said that the value will be 3, 3 and 2. First one is in this case for to 1 to 4. First value is 1 to 4, and then 15, 17 and 27, and then 3, 10 and 11. The value is showing the column wise, not the row wise. Data frame. Data frame is another structure where we can store the data by using the common data frame. Here I have taken an example of a bird. Suppose there are different type of birds are given, and there where the birds are found. This is also given. So in the data frame, I have just first write the garden, and then the number of the birds are counted in the values are there, and this is the location where the data is found, and then I have write the row names like the which type of birds are seen in this positions, and then print their bird. We can see the data is given in the form of this. Where in the garden, this is the column. In this column, the birds names are given, and in this way, that now where the birds are the birds count is taken from, it is also given. Now factor. Factor are also data objects that are used to categorize the data and store its level. Factors can store both string and integers. Columns have the limited number of the unique values, so that the factors are very useful in this column. It is very useful in data analysis for statistical modeling. We use the command factor for using the command. In this case, first we take a data. This is right, wheat, pulse, and the maize, and the wheat, and this is there are 3 types of data are there, and then print the data, and then we want to check the data whether it's a factor or not, and last one is the factor data, and print the factor data. If I take the output, in the first case, when I print the data, it is so that the values which are already included, and then the print is factor of the data. It is a factor data or not, this say that is false. It is not a factor data. And then factor data, we just transform the data according to factor. So just write factor and the data. We can see that the data is different now from the first case or second case. In the first case, the values are written in the categorized form, like the double in the between the double quotation. In this form, there is the values written in the factor form. And there is a label. Labels are there. Labels mean the which type of variables are included there. In this case, there are 4 types of variables are there. First one is maize, pulse, rice, and wheat. And again, if I want to check the data is factor or not, then we print the data, and we can see the true answer that it is already converted in factor data. Then string in R. String is sequence of character. For example, statistic. For example, we can take the statistics. In this case, there are different characters are there. We can define the data by using the double quotation or the single quotation. If I write the course as statistics class, it is so that the statistics class in the double quotation. And if I want to see that the double quotation, it's also see that the will come in R programming also in the double quotation form. The loops are very important for the R in any kinds of program, in any kind of function writing. In this case, I have discussed only 3 types of loop. First one is the for loop, then while loop, and the last one is the break loop. For loop used for the criteria when, in this case, we write the statement in this form like the statement, and it is the number of the sequence, then the last time of sequence is encountered, and the statement. It is gives an iteration. If it is just false, then it's again need to go to the sequence, and again we do the same loop. And if it is true, it exists. It is exit. And the comment can write in the form of the for. And in the for, we can write that the from which value to which value we want to check the value, and there is statement, and complete the comment. Suppose in this case, I have used the crop data in tons. The data is given in the yield of C. It's the vector form right in there. After using the for command, for is equal to I is equal to 1 to 4, print the yield value. Like if I in this case, the data print for the I 1 to 4 value. We had only 4 values, so it is coming from 20. It is from 25, 30, 28, and 20. It's print the values. While loop used for the it is a control statement that will run statement of or statement or a set of statements repeatedly unless the given condition become false. It is also the entry controlled loop. It is in this loop the test condition is tested first and then the body of the loop is executed. The loop of the body should not be executed if the test condition is false. In this case, there is while, and then the for which condition we want to check, and then the statement. The diagram is like this. In this case, just write the statement. It's go for the iteration. It's the condition is true. Then again for the statement, it is false. It's exit. In this case, I have put there the number is the marks are given for the suppose the marks of student is given in the examination 65, 72, 858, 80 and 69. If I print the while loop, while then while loop is I is equal to length of the marks and then the command is started, and then the statement is print the marks is I is equal to I plus 1, means if I is equal to 1, then it put the value 2. If I is equal to 2, then its value is give the value 3. In this case, I start the value from the I is equal to 2. So you can see that when we after run all the program, then we can see the output is 72, 58, 80 and 69. In this case, if I as I said the I value is 2, is give you the first second value and then third and the fourth value, not the first value. If I put it I is equal to 1, is give the 65, 72, 58, 80 and 69, all the values. Now the break statement. Break statement used to immediately terminate the loop in R. When the break statement is encountered inside a loop, the execution of the loop stops and the control moves for the next statement after the loop. It is commonly used when the specific condition satisfied. There is no need to continue the loop further. We can use break statement can be used in for, while and repeat loop. In this syntax will be for loop, the syntax will be for I in sequence, then the commands, and if the condition to break. And the while loop again the same like while and the condition, then the commands, and if the condition and break. This is the diagram. This diagram is same like the previous one. Like the first we write the statement, is go for the condition, check the condition. If it's satisfied, then go for this iteration, and this false, and again they go for the statement, and if it's true, then it's break. Suppose in this case, I have put the marks of the students and their name, and the value is given. The marks is given like 65, 72, 55, 80 and 869. I started the initialize the value from I is equal to 1. While I is the length of the students, and if the marks of I is less than 60, it's so that the student's mark is less than 60 found and loop stop and break. And how we the print marks would be print the data and paste the student name and the marks and the marks number. And I is coming for I is equal to 1, I plus 1. Now after that, in this case, we can see that the first value 65, 72, 55 and 80 and 69. After running the all program, we can see that the marks is Amit marks is 65 and Riyaz marks is 72. And then the next command, then the next output is student marks less than 60 is found. Means in this case, we can see the first value is greater than 60, so it is go for that, and then 72. And when the value is less than 60, it's so that the student's marks is less than 60 found, so loop is stopped. Now next part is data visualization. In this case, I have taken a data of the yield, and then we plot the histogram. After in the histogram, we can when we use the histogram, when the data is continuous, only when these cases we use the histogram plot. In this case, the yield is the x and y variable are defined, and main is give you the legend of the top file. The bottom of the top of the diagram is histogram of yield, and x lab give you the yield, and the y give you the frequency. In this case, I have limit the y limit is 0 to 6, and column is color is light green. Next part is the box plot. In the same data, if I plot it for this data set, I have plot the box plot. From the box plot, we can see that this two value gives you the extreme value of the data set, and the thick line give you the median point. In this value is our Q1 and this value is our Q3. This is for the box plot is plotted for the interquartile range. For the data if we want to know how much data is spread along the data set, so we use the box plot. There is a bar diagram. In this case, I have taken data rice, wheat, maize, pulse, and barley, and the production of these products. This is the products is given, and if I use the comment bar plot, it gives you the bar plot at the production tons wise. And from this, we can interpret the data like the maize has the maximum production. Then I have taken data set to summarize. So suppose I have taken the data set of the wheat, rice, and wheat, rice, corn, like this data, and the region where the data is coming from, north, south, and the north and south. From the if I in a plot I have plot the data like wheat, rice, and corn, and then just set there whether the data is harvested in the north, in the south, or in any other direction, and then the yield value. And then I have used the summary statistic by using summary and the crop data and then yield. Only this value. Whenever I write crop data and yield, is give you only this value, because this data is given a data frame form. It's give you a matrix. And after running I give you the 5 point of the summary, like the first minimum value of the data set and the first quartile, then median, then mean, then third quartile, and the maximum value in the data set. By using the mean yield by crop, is give you the where the data set, how much the data set is harvested. Like in the corn, is the yield is 5.35, and the rice is 4.25, and wheat is 3.50. And last one is when I plot the data, aggregate yield versus yield described by crop plus region, it give you the which position the data it is plotted. And from this we can say that in the maximum value is the 5.6. So corn in the south position has give the maximum yield. Last one is the BMI plot. In this BMI plot, I have plotted some patient of and their height and their weight, and then we calculate the BMI. And after calculate the BMI, I just print the data. This is the data set after the calculating the BMI, and then I plot the data in two sets. First one for the histogram, and second for the scatter plot. In the histogram, we can see that the data is given frequency, largest frequency is 2, and the data, and in the scatter plot, we can see the data set is maximum BMI is 26 for the 1.28 height. Thank you for your attention. If you have any question, please ask me.